Morning everyone present here. Let me introduce myself to you. My name is Yamuna Chapragod and I'm from CSM. My roll number is 23 4G183313. Today I'm going to talk about 2% zero sum problem from the subject optimization technique. Introduction to the 2% sum problem. In game theory, 2% zero sum problem is a strategic interaction where two players compete directly and one player gain is exactly other player's loss. These games are called zero sum because the total payoff remains constant. Any advantage to one player comes at the equal cost to the other. Let's discuss about some key points. Players typically labeled as player A from row player and player B from the column player. Strategies players have a finite strategies. The outcomes depend on strategy play chosen. The and now payoff matrix is a matrix that shows the payoff for player A for each combination of strategies. Since it's zero sum, player B's payoff is just the negatives of A. Now the objective of this is to a player A aims to maximize the payoff and player B aims to minimize the player's A's payoff, that is minimize their own loss. Solution methods of this are dominance, eliminating dominator strategies to reduce the matrix size, saddle point if maximum players A worst outcomes equals the minimax, the player B's worst case closest then the saddle point exists indicating the pure strategy. Fixed strategies and linear programs. No saddle point exists. Most advanced, like simplest method are used to solve the game using the properties. Why it matters? These types of games model real-life competitive situations from economics and politics to AI and military strategy, where each player must anticipate and respond to others' choices. Now let us take an example of this. Given string is 2 minus 2, 4, 1, 6, 1, 2, 3, minus 3. And we suspect this represents a matrix since there are 13, 17 numbers and the last 7 appear extraneous. By forming a 3 by 7 matrix from the given numbers. The first step is dominance check. Check for dominated strategies, that is player A rows. Compare A1, A2 and A3, neither dominates the other. No row is strictly dominated. So we check the dominated strategies from player B columns. Column B5 has 6 minus 3 minus 3 and column B4 has 1, 3, 2. Since B5 yields higher or equal payoffs for A ever, so B wants to minimize A's payoff. B5 is strictly dominated by B4 and it can be removed. After removing the numbers, we get the reduced matrix as the following. Now let us go for the step 3 by remove saddle points analysis. Row minimums, player A's worst case payoffs. For A1 we have minimum of 2 minus 2 4 1, that is minus 2, and for A2 minimum of 1 1 2 3, that is 1, and for A3 minimum of 2 0 6 2, which is 0, and minimax of all these that is maximum of all these numbers is minus 2 1 0, we get 1, and similarly, we do it for the column, that is player B's worst case outcomes. Max B1 for max of 2 1 2 is 2. For B2 max of minus 2 1 0 is 1. For B3 max of 4 2 6 is 6, and for B4 max of 1 3 2 is 3. Among all these, the minimum of for mini max we take the minimum, that is 1. And we are getting the conclusion that since minimax and maximum is same, that is we got 1. The game has a pure strategy saddle point. The value of the game is 1. Optimal strategy for the player A, which would be the play row A2, and for optimal strategy for player B would be play column B2. Now as we have seen below, minimax and maximum is 1. The final answer of our problem would be 1, and the game value would also be 1. Thank you everyone for giving me this wonderful opportunity. Have a nice day ahead and thank you.